Okay guys, this stuff is from 13.4. We're using the inverse buttons, and so when we talk about, first thing before we get into the problem, when we talk about finding the inverse of a function, a trig function, it's going to produce an angle every time, either in radians or degrees, depending on what our calculator has as a mode at the current time. What we need to understand though is that our calculators are all programmed to give sine inverses in certain areas, cosine inverses in certain areas, and tangent inverses in certain areas. And so whenever we get a value from our calculator for the sine inverse, it will live between negative 90 degrees and positive 90 degrees. That's the way that we talk about this, going negative 90 or positive 90. This is where all of the y values live, or all the values for sine live when we use the sine inverse. Now, can we reflect that over here and talk about them over here? Yes, but the calculator will only produce answers over here for sine. For cosine, it will only produce solutions in this region. So cosine inverse will be between 0 and 180 degrees. Anywhere in there works well, or between 0 and pi in radian terms. Then we have to talk about tangent. Tangent also, just like sine, lives in these two areas. The only difference is it will not give us an answer for 90 or for negative 90, because those are where tangent is undefined. When the x value that goes in the bottom is 0, it could be 1 over 0 or negative 1 over 0, those are undefined values. And so the tangent inverse of 90 is undefined. And so we won't be allowed to use the actual 90s. But everything else is fair game. So this idea of where all your values are coming from is important for when we go and get those inverses and get those degrees. We'll know where to expect our answers. So for instance, for number 5, it asks us to find, to simplify this, to evaluate what we have. It also asks us to do this both in radians and in degrees. And it asks us to do this without using a calculator. So I'm going to go back to this unit circle, and I'm going to look in the area where cosine is. And I'm going to look where x over r, because cosine, remember, is x over r. I'm going to look somewhere where this would be equal to 0. Because cosine of theta, I want to know what theta gives me some form of 0. Well, that means I'm looking for places where x is 0, and that happens right here. I see that x is 0 right there. And so I think that 90 degrees is a place where if I plug in, cosine of 90 would equal 0 over 1, and that would equal 0. And it's in this region that cosine lives in. So I'm going to say that the cosine inverse in degrees of 0 is 90 degrees. Now I want to talk about that in terms of pi as well, in the radian measures. If I look back up here, the radian measure is pi halves. And so I'm going to come in here and say, or pi over 2. We really want to get to where we're comfortable with the change between them. We become comfortable with this unit circle and its measurements. On number 12, it asks for more of the same. It says, evaluate, this time with a calculator. Okay, and I didn't pull my calculator up, so we'll grab that real quickly, and it'll take just a minute for it to load. And while we're doing that, let me remind you that to get your review quizzes done on Moodle, there's always more to do. So we'll grab that, and now that we have that, let's go back here and grab this. All right. So we want to take the sine inverse of 0.18. So I have to press second sine, that's my sine inverse, of 0.18, close my parentheses, hit enter. 0.181. Okay, but I want to know what is that. Is that radians or is that degrees? When I press mode, there it is, it's in radians. So I'm going to say it's 0.181. So 0.181 radians. And then I want to do it in degrees as well. So I'm going to go back to my calculator. I'm going to change my mode to degree. And then I'm just going to hit enter because it's going to try to evaluate the same thing. And that means I've got about a 10.4 degree angle. 10.4 degrees. And those are the two answers that I would come out with as my answers for radians and degrees. That means that a 10.4 degree angle in a sine function produces 0.18. Same thing with this in sine function produces that result. Number 22, they're asking me to, again, do the same basic thing. I have sine of theta equals 0.15, and I want to find theta. To do that, I'm going to apply the sine inverse, because sine inverse and sine cancel out. But what I do to one side, I have to do to the other. So theta equals the sine inverse of 0.15. So I'm going to find out what angle, when I plug it into sine, produces 0.15. Now I remember, though, that in this picture here, sine lives between negative 90 and 90. What I'm being asked to find is something over here. So I'm going to want a picture of this here in just a bit when I'm doing this. I want to plot a picture to help me with this. So when I put this in my calculator, let's do it in degrees. Let's grab my calculator. I think it's still in degree mode. Yeah. So I'm going to hit second sine of 0.15, close my parentheses, and hit enter. And it's about 8.6. We'll say 8.6. So theta equals 8.6 degrees. Well, the problem is 8.6 degrees is right over here. But this is not where they asked. They asked me to find one that's over in this region. Well, remember, the sine value has to do with the y. So there's a certain y value here. I want another triangle that's over here that uses the same y value, or same height. Well, if I reflect all the way over here, I get the same y value. And so the question that they want is, how big is this angle that it would take to get there? From 0, how far would I rotate? Well, since this is 8.6 down here, if I take 180 and I subtract 8.6, I will get 171.4. Is that in the region they asked? Yes, it is. So that will be my theta. Just a little reflecting to do here and there. Nothing too horrible. Last question is just, hey, let's find theta for this triangle. We don't know anything but a 90-degree angle and two sides. Can we still do it? Yes, we can. We need to know from this guy's perspective, are we talking about opposite, adjacent, or hypotenuse? Excuse me. Whoops. All right. Sorry about that, guys. Doing two videos at once. So theta is opposite, okay, and a hypotenuse. So this must be the sine value. Sine of theta equals 5 over 8. How do I get theta alone? I use the sine inverse to both sides. So the sine and sine inverse cancel, and theta equals the sine inverse of 5 over 8. And I'm thinking that we want this in degrees, so I'm going to grab my calculator, pull it up, and I'm going to find the sine inverse of 5 over 8, and hit enter. I end up with 38.7. So I'm going to say that theta equals 38.7 degrees, and I am pretty happy with that. That's your assignment. I know there may be some questions. There's not a ton of work because a lot of it is calculator driven. But when there is work, please get it done and show what you can so that you have as much help as you need later.